Introduction to MLOps. In this particular video, we will cover overview of MLOps and its importance. We look at evolution of machine learning operations. We look at key concepts in MLOps which are versioning, automation, and monitoring. We look at MLOps versus DevOps. What are the similarities and differences? And finally, we'll do a hands-on where we'll set up a basic MLOps project structure using Git for version control, Docker for containerization, and create a simple model pipeline. So let's get started. Overview of MLOps and its importance. What is MLOps? MLOps, which also stands for Machine Learning Operations, is a practice that combines machine learning with DevOps principles to automate and streamline the life cycle of ML models from development to deployment and beyond. MLOps enables collaboration between data scientists, engineers, and IT operations teams, ensuring that ML models are reproducible, scalable, and maintainable in production environments. Why is MLOps important? Scalability. MLOps enables ML models to be scaled efficiently across different environments like local, cloud, or edge. Reproducibility ensures that models and data pipelines can be reproduced exactly as developed. Automation. It automates repetitive tasks like retraining, testing, deployment, and monitoring. Model lifecycle management. It provides a framework to manage and maintain models throughout their lifecycle, including monitoring performance and handling drift. Collaboration brings together cross functional teams, data scientists, ML engineers, DevOps, etc., for better productivity and smoother workflows. Let's look at evolution of machine learning operations or MLOps. First, traditional ML development. In the early days of ML, model development was a manual process. Data scientists focused on experimentation, model selection, and accuracy without much thought for scalability, automation, or deployment. Introduction to DevOps practices to ML. DevOps principles like continuous integration (CI) and continuous delivery (CD) started getting adopted in ML workflows. This marked the beginning of MLOps. The shift of modern MLOps. As organizations scaled their ML capabilities, the need for automated workflows, better monitoring, and reproducibility became crucial. Modern MLOps focuses on closing the gap between development and production, ensuring models are continuously integrated, tested, deployed, and monitored. Key concepts in MLOps. We have three of them: versioning, automation, and monitoring. When it comes to versioning, first we talk about data versioning, where we're tracking changes in data sets used for training and testing models. Model versioning, keeping track of different versions of the ML models. Code versioning, using Git to manage changes in the code. Next is automation. In automation, we have automating the model training, which automatically retraining models based on new data or performance metrics. We also have automatic deployment, which is CI/CD pipelines for automatically deploying models to production. Then we have monitoring, where we have model performance, monitoring the accuracy, latency, and other performance metrics of models in production. We also look at concept drift detection, where you identify when a model's performance degrades due to changes in data patterns over time. Finally, logging, collecting logs related to model inference, system performance, and errors for debugging and auditing. These are the key concepts in MLOps. Let's look at MLOps versus DevOps. What are the similarities first? Automation. Both focus on automating workflows to reduce manual effort. How about collaboration? Both foster collaboration between development, operations, and other stakeholders. Continuous integration, continuous delivery, CI/CD. Shared focus on creating pipelines that automatically test and deploy code, or models. Now, if you are familiar with DevOps, you probably knew these were the similarities. Let's look at the differences. Complexity of artifacts. DevOps manages code while MLOps manages code, data, and models. Experimentation in MLOps. MLOps emphasizes experimentation, which is hyperparameters, model architectures, which is less prominent in traditional DevOps. And then we have monitoring needs. In MLOps, models need to be monitored for both performance and concept drift, whereas DevOps primarily focus on system uptime and performance. Let's go into the hands-on where we'll be setting up a basic MLOps project structure. In this hands-on session, you'll create a simple MLOps project structure that sets the foundation for versioning, automation, and monitoring. So I would say follow along as and when we go through this video. If you have to pause somewhere, pause somewhere. There are four steps that will follow. Step one is set up version control using Git. Next, we're going to look at setting up Docker for containerization. Next, we're going to implement basic experiment tracking with MLflow. And then we're going to look at how to create a basic monitoring setup. So let's get started with our hands-on. Step 1, set up version control using Git. Now, first step inside here is to install Git on your machine. If you do not have Git installed, I would say go to git-scm.com and then follow the instructions for downloading Git. It will show you based on your machine what you need to download. Another option is if you have Mac, what I would say is you can just say brew install Git and it will install Git if you do not have it installed. Next step is to create a Git repository. To do that, first let's see, I'm on desktop right now. Let's make sure, yep, I'm on desktop. And here I'm going to create a new directory. I'll call it my underscore MLOps underscore project. And then I'll open this project or folder. So now I am inside the my MLOps project folder. Next, let's initialize Git repository. So once you have your Git installed, you can always give the command git and see if it's there or if it says command not found, but that's one way of doing it. And say git init. So it says that it has initialized. It gave me some warnings here, hints and stuff, but I am all set with my, if I look at here ls-a, which shows all files, I have .git file in there. Now clear this out. Next step is creating a basic file structure. So I'm going to take that folder that I've created here, open it in my Sublime Text, and here I'm going to create a basic file structure. So usually what I do whenever I create an MLOps project is I create a new folder. I'll call it data. This is where all my data goes. Create another folder, models. This is where my models will go. Create a new folder, notebooks. This is where all my notebooks will go. And finally, for the code, I am going to create src where my uh, training code will go inside. So next thing that I want to do is I can all everything is done. I can go here and I can say git add dot. This is to add the changes inside my git, and I can say commit -m, which is the message that I'm passing, which is initial MLOps project structure. So it says on branch master, nothing to commit since I have not added anything. So what I'm going to do is I am going to add a file inside my source, new file, call this train.py, my training file. So that file is there, and I am going to give a comment here, training source code, something like this. I'm going to go back here, git add dot, git commit, and I can, so that my commit is ready to be pushed wherever I want to push it. Now step number two. Step number two was, let's go back, setting up Docker for containerization. So what I'm going to do is I'm going to go and look for Docker. Can go inside Docker, and here I can download. It will tell me download for Mac, but if you have any other machines, depending on which machine you have, you can download that. Once you've downloaded it, it will add to your applications folder. It will give you step-by-step instructions, and then you can go ahead and open Docker. I have already installed Docker, so I'm going to open it here, and I have something here. I can always go ahead and delete. So it will probably look like this when you install it first time. It might have things based on what you've done before. I can delete everything that I have because none of that is something that I need. I have some volumes here, builds, bunch of different options that I've created before. So that's what is available, but it should look blank when you install it. Now, once you have this running, you can close this here, and I'm going to go back to my kind of to create a Docker file. So what I can do is I can go here and say Docker in it, and it will ask me what type of file you want to create. You want to create a Go server, Python server. I'm going to just keep it generic and say uh, other, and it will create some files for me. I'm going to clear this out, go back to my here, and you'll see it created Docker ignore, compose YAML file, Docker file, and readme Docker file. So these gets created automatically when you initialize Docker. So first thing that we want to do is go to Docker file, remove everything, and we are going to write some code here of what we need for this container. So I'm going to say from which version of Python do I want to use? Use 3.9 Slim. Next thing that I want to do is work directory / app. That's my working directory. Next, I want to install, if I want to install any dependencies, this is for, see, inside here, I'll say copy a file which I'll be creating in requirements dot text to the current, run pip install -r requirements.txt file. So it's going to install all the dependencies that are available. Like to make it capital. Next thing that I want to do is copy the rest of the code into my Docker. So for that, I'll just add the comment, copy the rest of the code. And what do I want to copy? Copy dot dot. Next thing, just to give you a good idea of what I'm doing here, command to run the model training script, which is the script, that training file that we created, train.py. That is what we've created. Let's make sure it doesn't, okay, it's not in the same folder. cmd python, what I want to use, src / train.py. So it's inside src train.py. So that's what I mentioned here. Next, let's create the requirements.txt file. So right here, I'm going to create a new file. Okay, let's save this first. Save this one as requirements.txt file, and inside requirements I'll need numpy. I'm just going to use some basic libraries. For example, I'll say I want pandas, I want scikit learn. These are the basic ones that I need, and they will be installed when my Docker runs or when my server runs. Now let's build the Docker image. To build a Docker image, we can run the following command in my terminal. I can go here and I can say docker build -t my project MLOps project latest dot. So this will build my entire Docker, and I think it's done, it's good. Next thing that I want to do is I want to run the container. Now to run the container, you use docker run MLOps project latest. Now my Docker is running. If you open the Docker application, you'll probably see that there is something running here, which is MLOps project latest is running right here. Now let's go to step number 3. Step number 3 is implement basic experiment training with MLflow. So let's open our terminal again. Let's clear it out. I'm going to open in virtual environment. So I'm going to say v environment. I'm going to call it ML flow app, and then I'll activate this by saying ML flow app slash bin slash activate. Oh, sorry, forgot source. There you go. So now I'm inside my virtual environment here. First, I'm going to install MLflow. So pip install MLflow. So that's being installed. While that is installing, the next thing that we're going to do here is we'll log a simple experiment where we'll create a we already created a train.py file, and inside that we'll create something that trains a basic ML model and logs the experiment in MLflow. So let's go here, or wherever our code is for train.py. Inside this, I am going to first import MLflow. Next, I need load iris. So that is coming from sklearn dot datasets import load iris for some datasets. Next, I would need a model to do the train test split. So that is coming from sklearn dot model underscore selection library import import. I want to get train test split. Next thing I need is the random forest classifier. So that is coming from sklearn.ensemble emble import random forest classifier. That's good. And next I need from sklearn metrics accuracy score to check the accuracy of the training. Accuracy underscore score. So I have everything that I need here. Next, let's load the data. To load the data, I am going to say iris equal to create a variable iris, and then over there I'm going to call the load iris function. That's where I get my data from. Now I'm going to split the data: x train, x underscore test data, y train data, and y test data. That is coming from my train test split, and I'm going to take the inside this my parameters are iris dot data, and then next is iris dot target set, and next is I'll have to specify the test size equal to 0.2. That means training is 0.8, 80-20 split. That's what I'm doing here. Next, let's start the MLflow experiment. So I am going to say with MLflow dot start underscore run. Inside this I'll first try to train the model, where I'm going to say model equal to random forest classifier, call that. Then I'll say model dot fit. I want to fit this model into my data, so I'm going to say x underscore train comma y underscore train. So I'm going to fit. Next I want to predict, so I am going to say predictions equal to model dot predict. That's the function based on x underscore test, and I want to check the accuracy, which is using the accuracy score, where I pass y underscore test and my predictions. So that kind of will predict. And then finally, let's log the accuracy. I'm going to say ml flow dot log underscore metric accuracy, and the value is accuracy that I get from there. So that kind of does what I need to do. I'll save this, and now let's run this run my training script. I'm gonna clear this out. Let's make sure that we're in the same folder? No, we have src, so that's where the training is. So I'm going to say python src/train.py. So I think that worked, and our training set is done. If you want to look at it, let's ML flow UI. Using this, what you can do is you can directly open your browser and you can go to localhost, which is 127, and on the port 5000 you'll probably see your run name here. It will create a random name and it'll say finished, and it will give you your model metrics here, 0.933333. You can see the accuracy that was logged. I can so I can close this and actually run it again, open it again, go back to my experiments. It has my second experiment that ran 9 seconds ago. I will show you what is the model metrics. This time 0.9, so it kind of changes because it's going to keep on testing with different random variables. And so that kind of shows you how you can implement your ML flow structure here. Our next step is to create a basic monitoring setup, if I'm not wrong. Let's see. Here it is. Step 4 is create a basic monitoring setup. Now in this particular case, we are going to use the Python logging module, which is a simple yet powerful way to log different levels of events in your model training and inference code. So let's look at some basic logging configuration. For that, I'm going to go back here and I'm going to import logging. And in here, I am going to add some basic configuration. That is by saying logging dot basic config, as the name says, is basic configuration. I am going to say here the level of logging that I want, level equal to logging dot info. That's the basic informational logging. I want to have that format in this particular, in a format which is percentage ASC time s dash percentage level name s dash percentage whatever the message is. That's what I want the format to be in. Next thing that I want to do is handlers. So for handlers, I am going to specify an array where I will say first object is logging dot file handler, and to that I'll create a file where it will log, which is MLOps dot log. That's what I'll call it. Next, I'm going to say logging dot stream handler. Kind of create a stream, and so there you go. So that's my basic configuration for this. Now if you want to do some more logging, I can just say logging dot info, and inside that I can say starting model training process dot dot dot. Next, if I want to add logging over, like let's say before I load the data, I can just say in here I can say, since this is before the loading data, so I'm going to say loading data dot dot dot. I can next have, after my loading data is complete, I can say data loaded and split into training and test sets. The next part here is where I am training the random forest model. So I can say logging dot info, and inside there I will say training the random forest model dot dot dot. I can do here say model training completed, and you can pretty much add something like this for predictions. you can say making predictions of test set, and then you can also at the end of it, if I want to show the info in here, since I'm going to use model accuracy and display the value, I'm going to say accuracy dot 4 f. I don't want too many decimal places. Save it, and now if I run it, it will give me all the logging. Also it will give me the logs here, show me the logs here, and have my logging here. So if you keep on running this over and over time, it will make sure that the logs are available. So this kind of completes our introduction to MLOps, where we went through the overview of MLOps and its importance. We went through the evolution of machine learning and operations. We looked at key concepts in MLOps, which was versioning, automation, and monitoring. And then we looked at the differences between MLOps and DevOps. And finally, we did this hands-on where we went through setting up the control set version control using Git. Then we did Docker for containerization. We implemented basic experiment tracking with MLflow, and finally created a basic monitoring setup. So if you have any questions or if you had any issues while following this, let me know in the comments and I'll get back to you.